To this screencast where we're going to be talking about linear curve fitting of nonlinear data. So I created an M file here, linear curve fitting example 2, and we're going to be working with example 4 from a previous video, and I'll just give a brief recap. We were given an equation, y squared equals a times e to the negative b over x, and we rearrange this equation in two different ways in the y equals mx plus b form. We did that one way right here and a second way right here, and we found that we can create two different plots that will both be linear, and we predicted the slopes and the intercepts. And in this video we want to prove that to ourselves, so we actually know that it's true and that this method works. Alright, so where do we start? First we have to assign some values, but before we can do that we have to solve for y based on our equation. So looking at this equation here, we see what y squared is equal to. To isolate y, we can just take the square root of both sides and we'd get y equals the square root of a e to the negative b over x. Okay, and before we can actually assign this y value, we need to assign values for the constants a and b, and also the vector x. So usually a good bet for the x values is from 0 to 5, and we'll suppress that. The linspace commands creates 100 values from 0 to 5. Okay, and for our constant a, because we have this square root right here, we're going to want to pick a positive value, so I'll pick just 0.9, suppress that, and b, let's just pick 0.2. And now, since we have x, a, and b defined, we can define our y, which will be equal to this up here, but we cannot type it exactly the same. We have to add the MATLAB language rules. So a multiplied, we have to add the asterisk. Exponent, we have to type exp. And then negative b, we have to add a dot because we're dividing by a vector. And there we go. Okay, and now we can create our plot. Let's look at the first result that we got. So we said we'd plot natural log of y squared versus 1 over x. So let's type that in. 1 divided by x, and then natural log is typed log. And for both of these we have to add the dot because we're dividing by a vector, and here we're squaring each term in the vector. And let's see what that plot looks like. Okay, as we predicted, it is linear, so that's good. Let's go take our magnification tool and see what our y-intercept is. So looking at this, we can kind of follow the line and see where that would intersect. Alright, to me it looks like it's about negative 0.1. And if we look here, we said that the intercept would be natural log of a. So what is that? Let's type it in. Negative 0.1. So that is consistent with our graph, which is good. And now we just have to check that the slope is equal to negative b or negative 0.2. And the way we do that is by using the data cursor, clicking 2 points. Alright, and we can move our figure over here, and we have the command window right here, and we can type our slope formula, which is y2 minus y1 over x2 minus x1, and we have x1 and y1 both right here. So let's type in those values. In the numerator we'll have the y2 minus y1, so we have negative 0.1542. Because it's negative, it'll be plus 0.1542, and in the denominator we have x2 minus x1, which is 0.2 444. And let's just pick any other point along here with our data cursor tool. I like this one. So we can enter in our y2 value. So negative 0.1815. And our x2 value in the denominator is 0.3808. So this right here is y2 minus y1 over x2 minus x1. And we got these values by picking 2 points in our figure. And let's see what that equals. Okay, it equals negative 0.2, which is consistent with what we said it would be. The slope is negative b. We have a b value of 0.2. Negative b is negative 0.2. So that's right. I think this calls for a celebratory comment. Okay, and since we already defined our x, a, b, and y values, to verify our second result, we just can go straight to plotting. And we said that we would plot x times natural log of y squared versus x, so let's type that in. First the x values and then the y values. It'll be x dot multiplied by log of y squared. And remember, if you're multiplying a vector, you have to add the dot, and if you're squaring it, you also have to add the dot. And natural log is log in the MATLAB terminology. So let's see what we get here by running this. And our plot shows up here, and we can do the same procedure. We get our magnifying glass, see what that is. It looks to me like our y-intercept is about negative 0.2, and in this case our intercept should be negative b, which is negative 0.2. So that's right, all I have to do is verify the slope once again with the same procedure by getting our data cursor. So I like to reset this to our original view. Getting our data cursor, picking 2 points. First, let's just take that one. And let's type that out in the command window, y2 minus y1 over x2 minus x1. And entering our x1 and y1 values, we have 0.2, 106, and x1. And let's pick a y2 value. Alright, that one looks good. So y2, negative 0.6842, and our x2, 4.596. Alright, so this right here is y2 minus y1 over x2 minus x1, which will give us the slope of the line, which is negative 0.1 approximately, and we said that the slope would be natural log of a, which, once again, that is exactly right. So what have we done here? We have not only verified that MATLAB can be used to check linear curve fitting of nonlinear data, but we have also shown that you can be given a general equation and you can manipulate it more than one way in the y equals mx plus b form. You can get more than one equation, and then with these multiple equations you can create different plots, and say this were experimental data and a and b were unknown instead of actually assigning these values, then we could solve for a and b with the slope and intercept here and again here in two different ways. And if you look, you see that the slope and the intercept values switch. The negative b and the natural log of a switch for both of these two cases. Alright, I hope you found this helpful, and if so, please check out the other videos or leave a comment below.